So this problem is on page 99 and it's number 84. So this problem generally has to do with memorizing what is soluble and insoluble, and depending on what class you're in, you'll either get a list of strong acids or strong bases, or you'll have to know what compounds are generally soluble or insoluble. So this problem is given with these net ionic equations. So it asks you to pair the net ionic equation with the picture of the diagram of the solubility. So first, I took some notes on things that I know about these compounds. So one thing that is always a rule is all sodium salts are soluble in water, because sodium is and usually makes up a lot of ionic compounds, so that means that it's completely soluble. MgOH2, if you don't know this already, you probably should know that MgOH2 is not a strong base. You'll have a list of strong bases and strong acids that you might have to memorize or that are given to you, so you know that MgOH2 is a weak base, so that means it's not going to be dissociated. And you could also kind of tell for the diagram by the mole ratio, which is 1 Mg2 plus to 2 OH minus. So for BaCO3, carbonates generally aren't soluble, so we're going to take that into account when we're looking at this diagram too. So for number 1, you can see here that sodium salts are all soluble in water, so we're definitely going to see that as A, because it is seen in the final answer as completely soluble. There's no precipitate at all, so we're going to say that 1 is A. Number 2 is MgOH2. So we know that's a weak base and it's not completely dissociated, but we can see down here in C that we can tell by the mole ratio, which would be Mg, and then there's 2 OHs. So we can assume that unlike this compound here, that 2, it would be C, because part of it is dissociated, which means that it is a weak base, but just because it's a weak base doesn't mean that it is a complete precipitate at the bottom. So for 3, barium carbonate, we know that carbonates generally aren't soluble, so we can assume that BaCO3 is B, also because all of the compounds have a 1-to-1 ratio. Thanks for watching.